Hello and welcome to Grade Up. Welcome to this lecture series on theory of machines and vibrations. In the last lectures, we have seen about the simple mechanisms, what are the simple mechanisms and the different types of inversions. Okay, and we have done all kind of study about the simple mechanisms. We have also seen some previous year gate questions in the last lecture. So in this lecture we will start some kind of motion analysis. Okay, so first of all, the basic motion analysis we will start with is the velocity analysis. Okay, we will start with the velocity analysis. So let us begin. What is velocity analysis? What is the eye center method or the instantaneous center? Okay, the velocity analysis and the instantaneous center method that is given by Sir Arnold Kennedy. Okay, suppose this is a link AB, and this link AB at a position, it is having a position like this at time equal to t, and then at time t plus dt, this link is in some kind of a general motion. This point A has traveled to a new point, that is A1, and this point B has traveled to a point B1. Okay, so basically what this link is doing, this link is in a general motion, and this link is in a general motion, and this is A point is moving with a velocity of VA, and this B point is moving with a velocity of VB, and this both the links are basically, they are rotating or they are moving about this point, that is IAB. This is the instantaneous center of rotation of the link AB. Okay, so in general, when a link moves, its instantaneous center changes. Okay, its instantaneous center changes. Then the locus of instantaneous center for a link in its motion is known as a centroid. Means the locus or the line along which the instantaneous center for a link moves is known as a centroid, and the locus of instantaneous axis of rotation for a link is known as exode. Okay, in a general motion, what is a general motion? Like there is any link and it is in a general motion. Suppose it goes like this after some time. This is a link AB and this is A dash B dash. It becomes A dash B dash after some time. So this general motion, the centroid or the locus of instantaneous center is a curve, and the exode, that is the locus of the instantaneous axis of rotation, is a curved surface. In case of pure translation, what is a pure translation? It's a pure linear motion. Suppose this is link AB and after some time it has moved to a new position, that is A dash B dash, along a straight line. This is pure translational motion. So in case of a pure translational motion, the centroid is a straight line and an exode is a plane surface. In case of a pure rotation, what is a pure rotation? That if there is any link or any element that is in a pure rotation, that is rotation about a point, so the centroid will be a point and the exode will be a line. These are some of the concepts about the centroid and exodes in some kind of motion, like a general motion, a pure translation motion, and a pure rotation. Okay, then we have to find out the number of instantaneous center or eye centers in a mechanism. If there are n links in a mechanism, then number of eye centers is given by IC2, that is equal to, or this is basically, you can say this is L, or this is L, so LC2, that is L into L minus 1 by 2. Okay, example, if there are number of links L5, then the eye centers is 5C2, that is 5 into 5 minus 1, that is equal to 10. Okay, so this is the number of eye centers. This question is also asked sometimes in the examination, that there are some number of links given and then it is asked that how many numbers of eye centers are there. Okay, then some basic eye centers in a mechanism. If it is a turning pair having link 1 and link 2, then the eye center is simply at the point where they are hinged, or a turning pair or a joint. So this is the eye center, that is I1, 2. If it is a rolling pair, then the rolling pair, in case of a rolling pair, the instantaneous center of rotation or the eye center is the contact point between the flat surface and the rolling surface. Okay, then in case of a sliding pair, please remember, in case of a sliding pair, the eye center is at the center of the curvature. If it is a plane surface, then the center of curvature of the link 1 and 2 will lie at infinity. Okay, similarly at this point, this is link 1, the plane surface, and this is a block, that is link 2. So the eye center of these two links will be at the center of curvature, and since it is a plane surface, the plane surface is having the eye center or the center of curvature at the infinity. Okay, so this is at infinity. I center will go at infinity in a direction perpendicular to the sliding surface. This plane is a sliding surface, so perpendicular to it, it will be at infinity. Okay, then in case of a convex surface, this is a convex surface. So on the convex surface, if a block is sliding, then the I center will be at its center. Okay, in case of a concave surface, this is a concave surface, and if this block is rotating, then this concave surface, the I center will be at I12, again at the center of this curve. Okay, now let us see some kind of example that how this was the basic what I taught you about the how to find the I center and how to find the number of I centers. Then I will tell you this concept through an example, that how we have to find the velocities and all, because we are doing the velocity analysis. So we need to know, or we need to understand that how to find the velocities of the things. Okay, or of the mechanism. Okay, so this is basically an example. This is a mechanism that the link OA has a length of 200 mm, AB is 1.5 meter. Say this is OA, this is AB. OE is 1.35 meter. This is OE, this is 1.35. BE is 400 mm, BE is 400 mm, BC is 600 mm, and CD is 500 mm. Okay, and then it is given that if link OA rotates at 120 rpm clockwise, this means this is the link OA and this is rotating in this direction at 120 rpm. Okay, so we need to find the velocity of the point C, of the point B, velocity of point D, and then the omega or the angular velocities of some of the links, that is AB, BC and CD. Okay, so how we proceed? Let us see how we proceed. In this case, first of all, we need to find some of the I centers. Okay, suppose this is link. In this, first of all, we need to find out that how many links are there. See, one is this fixed link, and this is also a fixed link, so this is also one, this is also fixed, so this is also one. Then this OA is second link, AB is third link, this whole link BC is one link, so this is 4, this CD is another link, that is 5, and this slider is another link, that is 6. Okay, so in this case L is equal to 6, then the number of I centers will be equal to LC2, which is equal to 6C2, which is given as 6 into 6 minus 1 by 2, that is 6 into 5 by 2. So we have 15 I centers, or 15 I centers in this case. Okay, then we can find out some of the basic I centers that we have already seen, that how to get those basic I centers. See, this is link 1 and this is link 2. So this is link I12. Okay, this is I12. This is 2, this is 3. So this is I23. This is 3, this is 4. This is I14. Okay, this is link 1. And this is link 4 and this is link 1, so this is I14. This is link 5, this CD is link 5, BC is link 4, so this is I45. Then this is link 6 and this is link 5, so this is I56. And then this slider is moving with the link 1 with respect to link 1, so this is link 6, so this will be your link I16, because this is a slider moving, so link I16 will be along this line. Okay, this will be along this line, I16. Okay, then we have to find that. So see what are the links possible, that is I12, I13, I14, I15, I16, I23, okay, I24, I25, I26, I34, I35, I36, I45, I46, I56. So how many links? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So these are all the 15 I centers that are present in this mechanism. We have already found out I12, so I12 have already been found out. I23 have already been found out. Okay, these are some of the basics. I14 has also been found out. I14, sorry, this was I34. Okay, this was I34, this is I14. I34 has also been found out. I45 has also been found. Then what else we have found? Okay, these all we have found. Then next we need to find I56 also has been found out. Okay, then we need to find I13, I15, I16, 24, 25, 26, 35, 36 and 46. Okay, so for this what we have to do, let me tell you how to find this. See, first of all, this is a, please remember that this is a mechanism having 6 links. So how to find this? We draw a regular polygon with the number of sides equal to the total number of links. In this case, the total number of links is 6. So we will draw a polygon, a regular polygon having a side equal to number of links, that is number of links, that is equal to 6. So this is 1, and name it like this: 3, 4, 5 and 6. Okay, then what you do, you encircle it. You encircle it like this. Okay, you encircle it like this, joining all these points. Okay, and then what you do, you please write down that which of the others you have to find out. Please let me write it again here. 1, 2, I12, I13, I14, 15, 16, 23, 24, 25, 26, 34, 35, 36, 45, 46 and 56. And what all we have found, please note it down from the previous slide. 1, 2, 1, 4, 1, 2 and 1, 4 has been found out. 2, 3, 3, 4, 2, 3 has been found out. 2, 3, 4 has been found out. Sorry. 4, 5 and 5, 6. Okay, 4, 5, 5, 6 and what else? Okay, these many already we have found. Okay, then else we have to find out. Okay, so for finding 1, 3, suppose we are working with 1, 3, that is I13 if we are finding. So what is the way how we can reach 1, 3? We can reach 1, 3 either by 1, 2, 2, 3. Okay, that is I12, I23. And also, if anything else we have found out, 1, 4 also. Okay, yes, like this. See, join this. Then I13 can also be reached in the way I14, I14 and I43 or I34. Okay, so this is the way how we can find link I3, where it is. Okay, go back to previous slide, note down this I12, 2, 3 and 3, 1, 4, 3, 4. 1, 2, 2, 3. Where is this? 1, 2, 2, 3. Okay, so this is 1, 2, 2, 3. Along this line, 1, 2, 2, 3, because this is 1, 2 and this is 2, 3. Then 1, 4, 3, 4. Where is 1, 4? This is 1, 4. And where is 3, 4? This. So along this line and along this line, where these two lines will meet, this will be link I13. This will be link I13. This one. Okay, this will be link I13. Then again, this has also been found. Then similarly, I15, I16, all the links we can find it out. Similarly, we can find all the links that we require by doing this. I will tell you just one more, rest you can find yourself. Okay, I15, suppose we move on for I15. How to find I15? How we can reach I1 to 5? 1 to 5 can be reached I14, I14 and 45, because 45 is already there, I45, and then 16 is there, yes, 16 we have found, and 56 also we have found. Okay, so I16 and I56. Okay, because 15 can be reached I14, 45, and 1 from 5 can be reached also 16 and 56, and 16, 56 is already there. Okay, so we can find that out. How? Let us see. See, 1445. This is 14, and where is 45? This is 45. So again along this line, and then 16 and 56. Where is 16? 16 is along this line, and 56 is along this line. Okay, so along this line, along this line and along this line. So where these two lines will meet, this will be I515. This will be link I15. So this is link I15. So similarly, we have found these two links. The rest you can try yourself. If you have any problem, you can ask. And so in this way we can find all the links, that the remaining links which are not known by the which are not found until now by the basics, you can find it using this method. And then how to, after finding how all these eye centers, what to do next, that we have to see. Okay, see, in this question only one input has been given, that the link OA rotates at 120 rpm clockwise. Okay, so using that information we will find what else all these 6 velocities, the 3 linear velocities and 3 angular velocities are asked. So we will see how to find all these. Okay, see what is given, it has been given that the n or the rpm of angle OA, because that has been given as 120 rpm. Okay, 120 rpm. So we can find the omega of OA equal to, you know, it is 2 pi n by 60. So this will be equal to 2 pi into n is 120 upon 60, which is equal to 4 pi radians per second. Okay, so this will be 4 pi radians per second. Okay, and then we can find the velocity of A, link A or point A, that is OA into omega OA. OA has been length of 200 mm, which is equal to 0.2 meter into 4 radians. So on calculating this, you will get this as 2.5132 meter per second. Okay, then similarly for the link 3, what is the link 3? See, this is the link 3 having the eye centers I13. Okay, because the link is 3 and we have to take it with respect to the fixed link, so it will be link 13. And what are the points included? That is point 1 and point A and point B. Okay, so for the link 3 I13 including the points A and B, omega 3 is equal to omega AB, which is equal to VA upon I13 A and VB I13B. We have to find out these lengths, because this is the diagram what we are doing, that is up to that is on a scale. So we have to find it that using in a graphical method by using some scale, proper scale. So this is 2.5132 divided by this length will come as 0.87, which is equal to VB upon 1.1. Okay, so omega 3, if you calculate omega 3 by this, if you calculate, you will get it as 2.887 radians per second, and VB you will find as 3.1776 meter per second. Okay, so this is, we have found omega 3, VA and VB. Next for the link 4, next we will see for the link 4, that is I14, and it will include, if you see the diagram, it will include point B and C. So omega 4 is equal to omega BC, which is equal to VB upon I14B equal to VC upon I14C. So if you calculate this, you will get this as 3.177 already previously calculated upon 0.4 equal to VC upon 0.2. So omega 4, if you calculate, you will get it as 7.944 radians per second, and VC you will get as 1.5888 meters per second. Okay, then for the next link, link 5, that is I15, this will take the points C and D. So omega 5 equal to omega CD equal to VC upon I15C equal to VD upon I15D. Okay, so this will be VC has already been calculated as 1.5888 upon this length is 0.077 equal to VD upon 0.53. So omega 5, if you calculate, that is omega CD, that is 2.0633 radians per second, or VD is equal to 1.0936 meters per second. So we have found 3 angular velocities and 3 linear velocities that was asked in the question. Okay, so this completes our question. Then we will move on to the next concept, that is the Kennedy's theorem. What does the Kennedy's theorem says? For the relative motion between the number of links, in a mechanism, any three links and their three instantaneous centers must lie on a straight line. These are the theorem of angular velocities. See, if this is link, this is a link M, this is a link N, so there will be two I centers on this, and this will be IMN. So according to this Kennedy's theorem, Vi, that is velocity of IMN, is equal to omega M IMN I1M equal to omega N I1N IMN, that is equal to V, velocity of IMN. Okay, so this is the basic equation of Kennedy's theorem that is to be used. Okay, see, then in this case we have three I centers, that is I1M, I1N and IMN. If these two, that is I1M and I1N, lie at the same side of I1M, because if these three lie on a straight line, then there can be a situation when these two lie on the same side of this, or these two lie on the opposite side of this. If these two lie at the same side of IMN, then their direction of rotation will be same. Means if one is rotating clockwise, then other will also rotate clockwise. If one is rotating anti-clockwise, then other will also rotate anti-clockwise. Then similarly, if their direction, if they lie in the opposite direction side of this IMN, then their direction of rotation will be opposite. Okay, then in the previous question we have seen, that omega 2 has been found out as 12.5664 radians per second. This has been given. Okay, so if we see in this, means solving that question again by this Kennedy theorem. So if we apply it on the links 2 and 5, we have, according to Kennedy's theorem, omega 2 I25 I12 is equal to omega 5 I25 I15. Okay, or we will find all these because this omega 2 is known, this is the length, this can be calculated using the scale. So omega 5 we will get as 2.0944 meter per, sorry, not meter per second, it will be radian per second because it is omega. Okay, then since you can see that I12, you will see in the diagram that I12 and I25, or sorry, I12 and I15 lies on the opposite side, of I25. Hence the direction of rotation of link 5 will be opposite to that of direction of rotation of link 2. And since the link 2 is rotating in a clockwise direction, the link 5 will rotate in a anti-clockwise direction. Similarly for others, that is taking 2 and 4 links, omega 2 I24 I12 will be equal to omega 4 I24 I14. Okay, omega 2 is already known. This length can be found using the scale. So omega 4 we will get as 7.7792 radians per second, and this will also be in the anti-clockwise direction. Then taking I45 or the links 4-5, omega 4 I45 I14 equal to omega 5 I45 I15. Okay, omega 4 has been found out. These two can be calculated, found out using the scale. So omega 5 will you get it to 0.0206 radians per second, and that too again in the anti-clockwise direction. Okay, so this is all how we apply the Kennedy theorem to find the omega of the given links. Okay, then there is one more example. You can see that this is a mechanism has been given, the configuration has been given like this, having 4 links joined by 4 turning pairs. Okay, these are the links has been given as A and A. Okay, other 2 links are not given, the lengths are not given because they are not required. So it is asking when theta, this is theta, when theta is equal to 180 degree and omega 2 has been given as 5 radian per second in the clockwise direction. So find omega 3. Okay, so let us draw this example at the condition given, that is at theta equal to 180 degree. Okay, So this is how it will look like. Okay, this is point, this is link 1, this will be link 2 when theta becomes 180 degree, and then this will be link this, and this will be like this. Okay, this will be link 3 and this will be link 4. Okay, so he is saying that omega 2, we need to find out omega 3. Okay, so for 2, 3, we need to find for 2, 3, omega 2 I23 I12 is equal to omega 3 I23 I13. Okay, omega 2 has been given as 5, I23, where is I23? This is I23, and I12 is this. So okay, this is I23 and this is I12. So this length is equal to A. This has been given, this is equal to A. Then omega 3 is to be found out. I23 is this, I13, where is 13? This is I13, we need to find out. Again, how? That this is a 4-link mechanism. So draw a regular polygon, 1, 2, 3, 4. You need to find out I13. I13 can be found out Y12, I23 and I14, I43. 1, 2 is this, 2, 3 is this. So along this line, along the line joining I2, 3 and 1, 2. Then I14, where is 1, 4? This is 1, 4, I14. And where is 4, 3? This is 4, 3, I43. So along this line, so this line, along this line and joining along this line. So this link, this point will again be I13. Okay, so I13 and I23, the distance is equal to, this is also A, this is also A, so this will be 2A. So omega 3 is equal to 5A upon 2A, which is equal to, this goes off, this is 2.5 radians per second. And the 3 links that are involved is I23, I12 and I13. See, I12, this is I12 and this is I13. They lie on the same side of I23. So the sense of rotation of omega 2 and omega 3 will be same. Since omega 2 is clockwise, so omega 3 will be 2.5 radian per second also clockwise. Okay, I hope you get this about the Kennedy theorem. Okay, so one more, find the location of I center I24. Okay, this is link 2. This is link 4. See, I24, this is again a 4 bar, means a 4 link mechanism. Okay, link 1, 2, 3 and 4. I12, see, 4, 1, 2, 3 and 4. You need to find 2, 4. So I24 can be found out using I23, I34 and I12, I14. How? See, I23, where is I23? This is, because this is link 2, this is link 3, so this is I23, okay, and I34, where is I34? This is 1 and this is 4, so this is I34, okay. So along this, and where is I12? 1, 2 will be along this, okay, infinity, because this is a plane sliding surface, so the I centers lie at direction perpendicular to the slider at infinity, and I14, 1, 4 will be along this perpendicular direction to this line, because this is also a plane surface and it will again lie at the infinity along the perpendicular to this surface. Okay, so the basic misunderstanding which the students get, or because this is a previous year's question, so many have marked the answer at this point as equal to I24. Okay, what do you feel? Is this the correct answer? No, this is not the correct answer, because these two lines are not meeting here, because these two lines are at infinity. Okay, because these 2 points are going at infinity, so you cannot make a point at this like this. So you can say that I24 will also lie at infinity. That's it. Okay, so I24 will lie at infinity. Okay. So this is all about the velocity analysis that we have covered in this lecture. In the next lecture, we will see some more analysis of the acceleration, because the velocity has been done, then the acceleration we will move on in the next lecture. Till then, if you have any queries, So you can ask us on the GradeUp app. You can download the app. You can solve the quizzes, the mock test, keep practicing the questions, and also if you have any comments about the content and all, you can also tell us about that also on the GradeUp app on the website. Till then, keep learning, keep watching the videos, keep taking the help of these courses to enhance your learning, and I hope that these courses are helping you out a lot in your preparation for the GATE examination and the other examination. If you have any queries and if you have any feedback, you can please write to us on the GradeUp app on the website. Till then, keep learning, keep growing. See you in the next class with some more lectures. Okay, till then, thank you and goodbye.